Hi guys, so I'm going to try to go through the Unit 7 review packet. I might have to do this in more than one video, but I'm going to at least start it here. And if you notice, the answer key that I gave you only had the answers. I didn't have the work worked out for you because I kind of want to go through step by step. I don't want people just copying. Now, obviously, some people can just copy, but at least you can hear what I'm saying as we go through it. Okay, so I'm just going to go through it, each problem, and explain to you how I did it and how I got it so that maybe you can learn, or if you made a mistake, you can learn from your mistakes. If you got the answers right, you can just fast forward to the problems that you need help with. So here we go. Number 1 is the square root of 24. Remember, the first thing you need to do is prime factor that. You can use a factor tree, you could use your calculator, and then you need to write down those prime factors. If you don't know how to get prime factors, let me know and I can teach you that separately, okay? So 2 times 2 times 2 times 3. Put a dot there so we know, okay? Remember the silly story I taught you that this is like a jail and these guys want to get out. You can only get out if you have your twin. Now, for those of you who showed up to my Google Meet, you know the rest of the story that Miss Sally told. But we're just going to go with something horrible happens on the way out and only one of them makes it out. Left behind, because they don't have twins to help them escape, are a 2 and a 3. So we multiply the 2 and the 3 together, and that's how we get 2 root 6 for number 1. Okay? Number 2. And I'm going to move quickly, but you can always just pause it if you need more time with something. Okay? The square root of 108. Pretty much the same as number 1. We just need to prime factor it. This might take you a little longer. I've been doing these numbers for years, so I can do it a little bit quicker. So it's 2 times 2 times 3 times 3 times 3. Okay? So I'm going to look for my pairs and see who can come out. And the first set of pairs I see is a set of 2s. So those two numbers can make their escape. One makes it out. So we have a 2 on the outside. I now also see that there's a set of 3s that can make it out. Now, not all 3 of them. 2 of them have to decide to go together and 1 of them has to get left behind. So there's always the sad person left behind. So that 3 comes out. And remember, when they come out, they get multiplied together on the outside. And then we had that lonely 3 that didn't have a partner, and so he got left behind. So that's the square root of 3. And so my final answer is 6 root 3. Okay? Number 3 is the square root of 8 times the square root of 6. Now, if you remember back to the videos, I told you got to multiply the outside times the outside and the inside times the inside, and then simplify. Well, the outside here, if you don't remember, there are invisible ones out here. Remember, in algebra, there's a lot of invisible ones. And so you can make them visible if you need to. You don't have to. So really, 1 times 1 is 1. And on the inside, we have 8 times 6. But instead of writing a 48, I'm going to prime factor each of those numbers because I'm going to need to see what can come out. So 8 can be, let me color code it. 8 can be prime factored as 2 times 2 times 2. 6 can be prime factored as 2 times 3. So instead of multiplying, get 48 and then prime factoring, I just prime factor from the beginning. Okay, it's just one less step. All right, so on the outside, we have a 1 kind of waiting around. I put the multiplication so I remember what happens. I look for my pairs. My first set of pairs are my 2s. Only 2 of the 2s. They have to do rock, paper, scissors to decide who's going to make the escape. They come out. Something horrible happens. 1 of them makes it out. Actually, they don't have to do rock, paper, scissors because look what happens. There is another set of 2s here, and so they can make it out. And they come out and get multiplied by what's waiting on the outside. The 3 is our left behind. We don't always have a left behind. If there's nothing left behind, then we don't have a square root anymore. We can let the prison collapse. But this one does have a left behind, and that's our 3. And so our final answer is 4 root 3. Okay? Okay, 4 steps it up a little bit. Number 4 has some numbers on the outside besides the ones. But that's not a big deal. We just talked about that. So we have 3 root 12 times 5 root 6. We just do outside times outside. So if you know 3 times 5, you can immediately write 15. You don't have to write 3 times 5 because there's no escaping once you're on the outside. Now on the inside, we have a 12 that can be prime factored. So 12 is 2 times 2 times 3. And then we have the 6 on the inside that can also be prime factored to 2 times 3. Now our 15 is waiting on the outside to be multiplied by whatever escapes. We have a set of 2's that can escape. Only one set. Here we go. Okay, those set of 2's are going to escape and get multiplied by what's on the outside. Now we have a set of 3's. They don't have to be next to each other, okay? They can always move around if they want. We have a 3 here and a 3 here. And multiplication, you can change the order, so it doesn't matter if they're next to each other. Okay, that's the commutative property of multiplication. And so those 2 come together, make their escape. One of them doesn't make it. And then we have a left behind in this case. In this case, the 2 is left behind. Okay, so then we have the square root of 2. So then we do 15 times 2 times 3 is 90. And then we have the square root of 2 on the inside of the radical. And that's our simplified answer. Okay? Number 5. Number 5 is the square root of 27. And under that square root is also an s and a u to the third. Okay, so I'm going to prime factor all of those. 27 is 3 times 3 times 3. S to the first is just s, and u is u times u times u. Okay, I'm going to go through and look for some partners here. All right, first partners I see are my 3's. So I have a set of 3's that can come out. And when I have a long list like this, I like to circle who's left behind also as I go. So the 3 comes out, and one of the 3's get left behind. So I'm going to circle him so I remember him. The s does not have a partner, so s gets left behind too, circling that one. There is a set of u's. U, oops, that's not the color I want to use. I wanted to highlight. Here we go. Okay, the 2 u's can come together and escape. And when they do, they get multiplied by what's on the outside. However, we also have a u left behind. So I'm going to circle it so I don't lose it. I circle them on purpose because if I get a long string of numbers and letters, I want to make sure I don't lose who's left behind, okay? And so then I have the square root of 3su. So my answer is 3u square root of 3su. That's my simplified answer. It actually looks a little more complicated, but again, you need to simplify it to the most simplest radical way. So that's number 5. Okay, let's do number 6. Number 6 is one where there's going to be a whole string of numbers, so I want to be careful that I don't lose any. It's 108, x to the 6th, y to the 4th, z to the 5th. Okay, I'm going to prime factor 108. Now, if you were smart, you looked back and you saw you could prime factor 108 in number 2. We'd already prime factor that. Not if you're smart, if you realized it. I know, I didn't realize it till this year. I've been doing these problems forever. So 2 times 2 times 3 times 3 times 3 is 108. Because that's 4 times 2. Yep, okay. Then I have 6 x's. 1, 2, 3, 4, 5, 6. 4 y's. I'm going to stack because I'm running out of room. And 5 z's. Okay? There is a shortcut to this. I'm not going to tell you the shortcut because you know I don't. But if you can figure out the shortcut, you don't have to show all of this work. There is a way to do this a little quicker, and you'll get it. It just, some people need to do it longhand for a while before they start to see the shortcut. And if I just tell you the shortcut, you may not quite understand what's going on. Okay? So we bring out the 2's, and they're going to get multiplied by something that, what else comes out? The 3's can come out. So we have a set of 3's, and they're going to come out, get multiplied by that 2. We have a 3 left behind. Because of so much going on, I'm going to circle it. Or maybe you're highlighting it. I mean, it's kind of up to you. Then I'm going to go to my x's and see what I can bring out. Well, I have one set of x's and another set of x's and a third set of x's. So I'm going to be bringing out 3 x's altogether. So 1, 2, and here's my third one, 3. Okay? Let's look at our y's now. How many of the y's can come out? Well, I have one set of y's and another set of y's. So 2 sets of y's are coming out. So here's a y and here's a y. Whoa, I didn't write the y. There we go. Okay? Now what about our z's? Oh, I need a different color. Let's do red. Okay, so I have a set of z's and another set of z's, and then I have a z left behind. So I'm going to circle that z left behind, and I'm going to bring out the 2 sets of z's. And again, like I said, there is a shorter way to do this, but this works perfectly fine. I'll get you the answer. So left behind in the radical prison is 3z. Now, if you give me this as an answer, you're going to lose points because you didn't simplify it all the way. Okay, so you got to go back and you have to continue with the simplifying. So 2 times 3 is 6. So I'm just going to put things that can go together. X times x times x times x is x to the third. And then y times y is y squared. And then z times z is z squared. And inside we have 3z. So not overly difficult, but there's a lot of places there that you could lose numbers and lose letters. So you got to be really careful and come up with a pattern that works for you. Maybe the arrows are too much for you. Maybe you're going to highlight. It's kind of up to you what works for you. Okay, so that's number 6. Let's move on to number 7. Number 7 is the square root of 8 over the square root of 6. The problem with this fraction is we cannot have a radical in the denominator. So we are going to have to rationalize the denominator, which in my little world means we need to orchestrate a jailbreak. That 6 needs out of there. Well, the only way to get that 6 out of there is to bring in another square root of 6 so that it has a partner to escape with. However, remember the rules of fractions. You can't just multiply a denominator that changes the entire value of your fraction. What you have to do is you have to multiply the top and the bottom by the same thing. So because the square root of 6 was brought into play, I also have to put a square root of 6 in the numerator. Now remember the rules of fractions. The rules of fractions say multiply the top times the top and the bottom times the bottom. So really what we have on the top is square root of 8. Well, guess what I'm going to do? I'm going to prime factor that 8. Okay? To just shorten up my steps. So that's going to be 2 times 2 times 2. And then I'm going to prime factor the 6. And so the 6 is going to be 2 times 3. Let me make my radical longer. I didn't make it long enough. There we go. On the bottom, we have the square root of, I'm not going to prime factor these because I orchestrated this on purpose for a jailbreak. So I'm just going to leave it 6 times 6. I already have my pairs. I don't need to undo them and then re-multiply. Okay? So then let's see what's going on in our numerator. Okay? So in our numerator, we have a set of 2's that can escape. So that's my first escapee in the numerator. And so maybe you want to draw the line so you remember we're still working in the numerator. I have a second set of 2's that can escape. So they get multiplied by the 2 that's on the outside. And then I have a left behind of a 3. So that's the square root of 3. On the bottom, I have a set of 6's. That was the whole point of this. That's where this all started, is we need to get the 6 out. So I have the 6's now can escape. And so there's nothing left in the radical. If there's nothing left in the radical, we don't write it. So now this is what we have. We have 4 root 3 over 6. You will lose a point if you turn this in because this is a fraction. And it can also be written as 4/6 root 3. Now do you see what I'm saying? The 4 over 6 can be simplified to 2 over 3, root 3 next to the 2. So this is the completely simplified version of number 7. Okay, let's go to number 8. Number 8 is the square root of 5 over the square root of 3. Whoops. Let me say that again. It is the square root of 5/3, which I'm going to rewrite as the square root of 5 over the square root of 3. Again, rules of fractions, I cannot have a radical in the denominator, so I'm going to have to rationalize the denominator. To rationalize the denominator, we need to bring into play another square root of 3. But whatever I do the denominator, need to do the numerator. So I put a square root of 3. And again, the whole reason we're doing that is because the square root of 3 over the square root of 3 is really just a 1. And so we're not changing the value of the fraction at all. We're just manipulating it to work for us. So in the numerator, we have 5, which is already prime, and 3, which is already prime. In the denominator, we have the square root of 3 times 3. So our numerator has no jailbreakers. So that's just the square root of 15. In our denominator, we better have something come out because that was the whole point of this. That's what rationalizing the denominator is. And so we have a pair of 3's that can come out, and we get a 3. This is the answer. Don't be sucked into the idea that that 15 and that 3 can cancel out, because really, if you put the square root of 15 into your calculator and hit enter, the square root of 15 is not actually 15. It's really 3.872983346 continued. So you can't just divide by 3 because you really don't know exactly what the square root of 15 is. So again, you can't have prisoners, the 15, interacting with the visitors, the 3. So that's why it has to stay that way. Okay? The square root of 15 is really not the number 15. All right, let's go to number 9. So we have the square root of 3/4 times the square root of 4/5. So I'm going to do 2 steps at once. I'm going to do top times top here and put that in a square root. So I'm going to write my 3, and then I'm going to prime factor my 4. Oops, that needs me to have a multiplication in between, or it looks like 22. Okay, and then in our denominator, I'm going to prime factor that 4. Well, let's do a different color because I did that on top. Okay, and so that's going to be 2 times 2. And then 5 is already prime, so I'm just going to leave it. Okay, now let's see what comes out of the numerator. Out of the numerator, we have 2 root 3. And out of the denominator, we have 2 root 5. Well, if you think back to number 7, what does 2 over 2 what happens with 2 over 2? Well, they can be simplified to 1. So really what we have is root 3 over 5, root 5. Now I want you to stop and think, is that an okay answer? And it's not. And I want you to stop and think, why is that not an okay answer? We still have a square root in the denominator. So we got to orchestrate a jailbreak. We have to rationalize the denominator. So I'm going to multiply the top and the bottom by the square root of 5. While 3 and 5 in the numerator are both prime, so that's just going to be the square root of 15. And maybe some of you have started to figure out the shortcut. If we have the square root of 5 times the square root of 5, my answer is 5. And so here's my final answer. Again, don't get sucked into the idea that you need to go a step further and say, oh, well, square root of 15 can be simplified by 5. Nope, that's not really a 15. It's a square root of 15, which cannot be simplified with a 5. Okay, so that's your answer, and just leave it that way. All right, let's go to number 10. Number 10 is the square root of 4y over 3y squared. Well, I don't like it written that way. You don't have to do what I'm doing here. There's a lot of different ways to get to the right answer. I'm just showing you one way. The square root of 4y over the square root of 3y squared. And again, I could pull out the y's in the denominator, or I can just orchestrate a jailbreak. So I'm going to get rid of that square root of 3y squared in the denominator. Again, how do I do that? I have to rationalize the denominator. So I multiply the denominator 3y squared, and whatever I do to the denominator, I have to do to the numerator. And so now when I rewrite the numerator and denominator, I'm going to prime factor anything I can in the numerator. So 4 is going to be 2 times 2. 3 is already prime, and then there's y that was next to the 4, and the y squared that was next to the 3. Okay? In the denominator, I don't really need to do anything, because what's the square root of 3y squared times the square root of 3y squared is 3y squared. So I'm going to skip that step. Okay? If you need to still write it, go ahead, but I'm going to start shortening it up a little bit. Now in the numerator, I can pull out a set of 2's, and I can pull out a set of y's. Remember, keep in mind, don't forget when they come out, only one of them makes it. So in the numerator, we have 2y outside the radical and 3y inside the radical. In the denominator, we have 3y squared. You're not quite done yet. Watch. I have 2/3 times y over y squared. I'm just separating things out, times the square root of 3y over 1. Well, can 2 over 3 be simplified? No, that's already simplified. But think back to your rules of exponents. How many y's are we going to be able to cancel out here? If I have 1 y in the numerator and 2 y's in the denominator, we can cancel out one of the y's. And where will the y's be left? In the denominator. And then we have that square root of 3y. Nothing can be done there. Again, don't fall into any kind of trap where that 3 and that y can be canceled out. That's not true. I just realized I had a mistake on my answer key. I worked so carefully on this. That's the correct answer there. Okay, we're going to do 2 more problems, and then I'm going to stop, and you can go look at the other video if you need to or not. So let's go to number 11. Number 11 is 8 over 3 plus the square root of 3. Now, I talked about this in my video where that some of you are saying, well, we could just multiply by the square root of 3, but all that does is bring in another square root of 3. This is where we have to bring in the conjugate. Remember, the conjugate is always, I'm going to put these in parentheses so I remember, is always the same 2 numbers, 3 and -3, but we switch the sign on the inside. So it was positive, so we put a negative. Remember the rules of fractions. Whatever we do to the denominator, we have to do the exact same thing to the denominator. So it better be parenthesis 3 minus the square root of 3 close parenthesis. So then what we actually have is 8 parenthesis 3 minus root 3 over parenthesis 3 plus root 3 close parenthesis open parenthesis 3 minus root 3 close parenthesis. And now we have to do some work. In the numerator, we have to distribute that 8. So 8 times 3 is 24. And 8 times negative root 3, remember there's an invisible 1 in front of that. So it's really going to come out as negative 8 root 3. Okay? We have to FOIL or box the denominator. If you don't know what I mean by that, I want you to go back to the video and watch it, because in my original lesson, I explained that. So I'm going to do it quickly here. It's going to be 9 minus 3 root 3 plus 3 root 3 minus the square root of 3 times 3. So I FOILed and boxed the denominator. And now I'm going to simplify. In the numerator, I have 24 minus 8 root 3. In the denominator, watch what happens. This is negative 3 root 3, and this is positive 3 root 3. They get canceled out. I have my 9, and then if I look over here, the square root of 3 times the square root of 3 times 3 is actually an escape, so we can bring out the 3. And so in the denominator, we have, oops, that's not multiplication. I was like, that's not right. We have minus 3. Sorry, wow, that was a big mistake. And so 9 minus 3 is 6. That's our denominator. Now, I would probably accept this. You'd have to talk to your teacher to see if they would take a point for this. But there is something that can be simplified here. All the outside numbers, all the visitors, are divisible by 2. And so we can divide everything by 2 here, and we would get 12 minus 4 root 3 over 3. And we could leave it like this. Okay, I'm not going to take a point if you don't notice that right here, but you might want to talk to Mr. McGrath and Miss Klanowski to see what their thinking is with that. Okay, one more, and then I'm going to stop and start a different video for the next part. Number 12. 5 over the square root of 7 minus the square root of 3. Again, we can't have those square roots in the denominators, but we have a subtraction in there, which means we need to rationalize using the conjugate. The conjugate is always the same 2 numbers, square root of 7, square root of 3, but changing the inside, or changing the sign on the inside. So we had subtraction, so we make this addition. Okay? Whatever I do to the denominator, I have to do to the numerator, or we've changed the problem and now it's not correct anymore. Okay? Our whole goal is not to change the value. We're just manipulating the numbers to work for us. So now what we have in the numerator is 5 parenthesis root 7 plus root 3. And what we have in the denominator is square root of 7 minus the square root of 3, close parenthesis, open parenthesis, square root of 7 plus the square root of 3, close parenthesis. So let's do some multiplying. In the numerator, we would distribute that 5, and we get 5 root 7 plus 5 root 3. And again, I'm either going to box or FOIL the denominator. And if you don't know how to do that, you need to go back to my video lesson and watch that. Okay, so we end up with the square root of 7 times 7 plus the square root of 7 times 3 minus the square root of 7 times 3 minus the square root of 3 times 3. Okay, the denominator can't be simplified, so we're going to leave that. I'm sorry, the numerator cannot be simplified, so we're going to leave that. The denominator can. So in this first term here, the square root of 7 times 7, a 7 can come out. Now, if you notice, and this is why we do this, we have a plus square root of 7 times 3 and a minus a square root of 7 times 3. Those are going to cancel out. That's the whole point. If they don't cancel out, you did something wrong. Okay? And then in our final term down here on the end, we have this minus the square root of 3 times 3. Well, what can come out of that? A 3. So we have 7 minus 3. So our denominator is 4. And there's actually nothing can be canceled out because the outside numbers are 5, 5, and 4. There's nothing that goes into 5, 5, and 4. Therefore, we are done. I'm going to pause it here. I'm going to create a second video for the next ones.